Hello students, in this video we will be seeing solutions for previous year JEE question paper, and we will be focusing on the unit called laws of motion. So the first question is, two particles A and B are moving on two concentric circles of radii r1 and r2 with equal angular speed omega. At t equal to 0, their positions and direction of motion are shown in the figure. The relative velocity Va minus Vb at t is equal to pi by 2 omega is. So here they have shown the position and its direction of motion. You can see here. Now angle, like from 0 it is rotated to pi 2 omega. Okay, so the angle rotated by each particle in the time of duration from 0 to 2 pi will be theta is equal to omega into t. Okay, and omega into, here t is pi by 2 omega. Okay, so it is pi by 2 radian. So it is rotated, it is rotated at an angle of around pi by 2 radian. So the position of the particles at t is equal to 2 pi, t is equal to pi by 2 omega will be like this. So initially it is like this as shown in the question, and after it is being rotated it will be like this. Okay, you are having two concentric circles like this. Now the position will change to here. So it is rotated by pi by 2. So this will come here. R2 will be here and R1 will be here. Okay, so if R1 is here means B will be in this direction and A will be in this direction. Okay, so this is the y-axis, and here the velocities of particles t is equal to pi by 2 omega r, Va is equal to minus omega r1I, and Vb is equal to minus omega r2I. Okay. So the relative velocity of the particles will be Va minus Vb. So which will be equal to minus omega r1I minus of minus omega r2I. Okay, so this will become omega r2 minus r1I. Okay, so this will be the relative velocity Va minus Vb. That's what they have asked. So initially they have given you the two concentric circles of radii r1 and r2 with equal angular speed omega, and at t equal to 0 their positions and direction of the motion is shown like this. And they asked us what will happen to the relative velocity Va minus Vb at t is equal to pi by 2 omega. So when t is equal to pi by 2 omega, the positions of A and B will be changing like this as we have drawn here. And from that you can easily find out the velocities of the particles at t is equal to pi by 2 omega will be, Va will be minus omega r1I and Vb will be minus omega r2I. So if you substitute in this Va minus Vb, you will be getting the answer as omega r2 minus r1 into I. So the correct answer is option number D, omega r2 minus r1 into I. Okay, let us now see the next question. A block of mass 10 kg is kept on a rough inclined plane as shown in the figure. A force of 3 Newton is applied on the block. The coefficient of static friction between the plane and the block is 0.6. What should be the minimum value of force such that the block does not move downward? And here they are telling us to take G is equal to 10 meter per second square. Okay, so you can draw the diagram for that like this. Here you are having the angle theta is equal to 45 degree, and here you are having the block over here, and this is the force F. Okay, and this is in this direction you are having 3 Newton, and here it is mg cos theta and here you are having Newton. Okay, so this is mg cos theta, this will be mg sin theta. Okay, so now you can add the forces. Here you are having 3 plus mg sin theta is equal to F plus F. Okay, 3 plus mg sin theta is equal to F plus F. So we know that F is equal to mu into n. Okay, so you will be having 3 plus mg sin theta is equal to F plus mu n, and mg cos theta will be equal to n. Mg cos theta is equal to n, because this side, okay, mg cos theta is equal to n, and you take this as equation number 1 and equation number 2, and you substitute the values of theta is 45 degree, you can substitute for that. Theta is 45 degree and m is 10 kg, okay, and the force is 3 Newton, okay, and the coefficient of static friction between the block is 0.6, okay, so mu value is 0.6. So if you substitute here 3 plus 10 into 10 into sine 45 degree is equal to F plus 0.6. N is mg cos theta again, so it will be 10 into 10 cos 45 degree. Okay, so if you solve this, you will be getting the F value approximately equal to 32 Newton. Okay, so you can solve it. It's a simple mathematical steps. You can just solve it. You will be getting the final force as 32 Newton. So the correct answer is option number A. So the minimum value of force which should be applied is around 32 Newton. So the correct answer is option number A. Okay, let us now move on to the next question. A block kept on a rough inclined plane as shown in the figure remains at rest up to a maximum force 2 Newton down the inclined plane. The maximum central force up the inclined plane that does not move the block is 10 Newton. The coefficient of static friction between the block and the plane is. So here, if you see, you will be having the block like this. You are having this angle here, and you are having the block over here. Okay, same like the previous question. So here you will be having this component as mg cos theta, and this component will be 2 plus mg sin theta, because here you can see it is 2 Newton. Okay, and you will be having here is n. Okay, so the maximum external force to incline the plane that does not move the block is 10 Newton. You are applying a force here of around 10 Newton. So here you are having 10 Newton. Okay, so now you can write down the equation for the first one. This direction you can write n is equal to mg cos theta. Okay, and F is equal to mu n. Okay, so similarly in this way you can write 2 plus mg sin theta is equal to mu mg cos theta, because F is mu n equal to F. Here you will be having F, so F is equal to mu n and n is mg cos theta. That's what you are writing here. Okay, so now we are having a force of around 10 Newton over here. So mg sin theta plus F will be equal to 10 Newton, or F is equal to mu n, which is equal to mu mg cos theta. Okay. So, if you solve this, you will be getting it as 2 plus mg sin theta plus mu mg cos theta is equal to 10. You are substituting here. Okay. So, this is equation number 2, and you will be having this one as the equation number 1. Okay. So, if you substitute the values like as we did in the previous problem, you can substitute the values of theta, the values of f, and value of m, what they have given here. Okay. You can substitute those values, and you can find out, you will be getting the mu value as mu is equal to root of 3 by 2. So, when you solve these two equations, you will be getting the value of mu as 3 by 2. Okay. So, just you can subtract these two, equation number 2 minus 1, you can see the mg and mg will get cancelled with each other, and you will be having mu mg cos theta equal to mu mg cos theta. So, you can 1 minus 2, if you do, you can easily find out what is the value of mu, which is equal to root 3 by 2. So, the correct answer is option number B. Okay. Let us now move on to the next question. A block of mass 5 kg is pushed in case A and pulled in case B by a force of F is equal to 20 Newton, making an angle of 30 degree with the horizontal as shown in the figures. The coefficient of friction between the block and the floor is 0.2. The difference between the acceleration of the block in case B and case A will be. Okay. So, first you write for case A or case 1, you can draw the figure for it. So, you will be having it like this. Okay. So, here it is F, which is equal to mu into N, and here you are having the force like this. That is what they have shown you in the figure, and you will have the sine component this side. So, it is mg F sine 30 degree, because theta is 30 degree here, and F cos 30 degree. Okay. And here it will be Newton N. Okay. So, you can write the equations like as we did in the previous problems. N is equal to mg plus F sine 30 degree. So, it is 5 into 10, because 5 kg plus F value is 20 Newton. That is what they have given you here. Okay, here they have given you 20 Newton. So, 20 plus sine 30 will be half. So, if you solve this, you will be getting the N value as 60 Newton, and F is equal to mu N, and mu value they have given you as 0.2. So, it is 0.2 into 60. So, if you solve this, you will be getting the F value as 12 Newton. Okay. So, the F value is 12 Newton. Now, you have to find out what is the net force. So, F is equal to MA1. Okay. F net is equal to MA1. So, we have to find out what is acceleration is. Okay. So, MA1, which is equivalent to F cos 30 degree minus F. Okay. So, MA1 will be equal to 20 into cos 30 is root 3 by 2 minus F is 12. So, M value is 5. Okay. So, when it is going here, on solving this, you will be getting the A1 value as equal to 1 meter per second square. Okay. So, roughly it will be around 1 meter per second square. So this is the value of A1 for the first case. Now in a similar manner you have to find out the A2 value for the second case. So you can go with the second case where the block is being pulled. Okay, so you can draw the diagram for that. You will be having mg over here, and you will be having the block like this. Okay, and here it is f sin 30 degree and n, and here it is f cos 30 degree, and here you will be having the net force F, and this is 30 degree. So in this case it is being pulled. So again you can write the F net, the net force, as F cos 30 degree minus F. Okay, so minus F is again minus mu n. F is equal to mu n. Here you can see now F is equal to mu n. You are going to substitute that, and you know that mu n means mu will be mu into mg minus n is mg minus f sin 30. Here you can see no mg minus f sin 30, because n plus f sin 30 degree is equal to mg, because this is this side and f plus sin 30 f sin 30 plus n is on that side. So n will be equal to mg minus f sin 30 degree. Okay, this you are going to substitute here. So you will be having it as f cos 30 degree minus mu into n. Mu n is mg minus f sin 30 degree. Okay, so you know that again f is equal to ma2. So f net is equal to ma2. So you will be having like f net is equal to ma2, the second acceleration. So a2 will be equal to f net by m. So here you will be having a2 is equal to f cos 30 degree minus mu mg minus f sin 30 degree divided by m. Okay, so you substitute the values of all the things, like you know what is f values. F is 20 and cos 30 is root 3 by 2 and mu is 0.2, m is 5, g is 10, and again f is 20, sin 30 is 1 by 2 divided by 5, m is 5. So if you solve this, you will be getting the a2 value as around 1.8 meter per second square. Okay, so you are having the a1 value as 1 meter per second square and a2 as 1.8 meter per second square. So the difference will be 1.8 minus 1, so it will be 0.8 meter per second square. So the correct answer is option number C, 0.8 meter per second square. Okay, so it's a very simple problem. Here they have given you two different cases. In case 1 you are pushing the block of mass as shown in the figure, and in case 2 you are pulling the block of mass. So you have to calculate the equivalent forces on either sides, and then you are finding out the acceleration by using the formula F is equal to ma. Okay, so you know what is forces, you know what is mass value. You are going to substitute and find out a1 and a2, and finally you are going to find the difference between the two accelerations. Okay, let us now move on to the next question. A bullet of mass 20 grams has an initial speed of 1 meter per second. Just before it starts penetrating a mud wall of thickness 20 centimeter, if the wall offers a mean resistance of 2.5 into 10 power minus 2 Newton, the speed of the bullet after emerging from the other side of the wall is close to. So here they have given the resistance offered by the wall as F is equal to minus 2.5 into 10 power minus 2 Newton. So the deceleration of the bullet is equal to A is equal to F by m. We know that F is equal to ma, so you are using that. Minus 2.5 into 10 power minus 2 divided by m is 20 grams. So 20 into 10 power minus 3. So if you solve this, you will be getting minus 5 by 4 meter per second square. That is the acceleration. Okay. Now you are using the equation of motion. V square minus u square is equal to 2as. 2as. Okay. So we know that v square is equal to 1 because the initial speed is 1 here they are given. So u is 1. So 1 plus 2 into a is minus 5 by 4 into the speed, which is s is 20 into 10 power minus 2. Okay. So it's s is 20 into 10 power minus 2, the thickness of the wall. So it is 20 into 10 power minus 2, the distance through which it is travelled. Okay. So it is 20 into 10 power minus 2. So when you solve this, you will be getting it as v square is equal to, so we know that this is 4 into 5, so minus 25 and 25 by 2. Okay. So when you solve this, you will be getting it as v square equal to 1 by 2 or v is equal to 1 by root 2. So which is equal to 0.7 meter per second. So the speed of the bullet emerging from the other side of the wall is equal to 0.7 meter per second. So the correct answer is option number D. Okay. So first you are finding out the acceleration and then you are substituting the values in the equation of motion. V square minus u square equal to 2as and you are finding out the speed of the bullet which is emerging out of the other side of the wall. Okay. Let us now move on to the next question. Two masses m1 is equal to 5 kg, m2 is equal to 10 kg connected by an inextensible string over a frictionless pulley are moving as shown in the figure. The coefficient of friction of the horizontal surface is 0.15. The minimum weight m that should be put on the top of m2 to stop the motion is. So here you can see they are telling us to add some weight in order to stop the motion. So how much weight has to be added on the top of m2 to stop the motion? So it's a frictionless pulley. So you can see that initially the mass is being it's just pulling it down, and how much weight you have to add in order to stop the pulling. So here you can draw the diagram for it like this. You are having the pulley over here, and here you are having mass m2 and it is going like this, and you are here having the mass m1. Okay. So this is a force is m1g and the tension will be acting in the opposite direction, and here the tension is here T and the force will be mu into m plus m2g. Okay. So you are adding a mass of m here. So here if you see you are going to substitute the values of m1 is equal to 5 kg and m2 is equal to 10 kg. So mu into m plus 10 into g is equal to 5, because m1 into g 5g. Okay. So g and g will get cancelled, and you know what is the mu value is 0.15 they are given here. Okay. So 10 plus m is equal to 5 by 0.15, or if you solve this you will be having m is equal to 23.33 kg. So this will be the weight which should be added on the top of the m2. So around 23.33 kg has to be added in order to stop the to put on m2 to stop the motion of it. Okay. So the correct answer is option number A. Okay, let us now move on to the next question. A block of mass m is placed on surface with a vertical cross section given by y is equal to x cube by 6. If the coefficient of friction is 0.5, the maximum height above the ground at which the block can be placed without slipping is. So here you can draw a diagram for it. You will be having x, y, and here you are having this y, theta, and you are having the block over here, mass. Okay, so this is the mass m. So here tan theta is given by, tan theta is equal to dy by dx. So which is equal to, y is x cube by 6. So d of x cube by 6 by dx. So if you solve this, you will be getting it as x square by 2. So at limiting case, theta should be angle of repose and tan of this angle of repose is mu. Okay, so mu is equal to tan theta. So here the mu value is 0.5. 0.5 is equal to x square by 2, or x square equal to 1 and x is equal to plus or minus 1. So you can substitute the values of x in this equation. Y is equal to x cube by 6. So in the first case, when x equal to 1, y will be equal to 1 by 6, and when x is equal to minus 1, y will be equal to minus of 1 by 6. So the maximum height above the ground at which the block can be placed without slipping is 1 by 6 meters. So the correct answer is option number A. Okay. So let us now move on to the next question. Two particles of mass m each are tied at the ends of light string of length 2a. The whole system is kept on a frictionless horizontal surface with the string held tight so that each mass is at a distance a from the center P. Now the midpoint of the string is pulled vertically upwards with a small but constant force. As a result, the particles move towards each other on the surface. The magnitude of acceleration when the separation between them becomes 2x is. So here you can draw the diagrams. You are having two particles like this. Okay, you are having two particles like this, and this is the distance over here, and here a force is acting like this, and you take this point as P. So you are having it like this. Okay, so this angle is theta and this one is theta. So the tension is acting in this direction, and this will be also theta. Okay, so here A naught and A naught, x and x. So at point P, 2t cos theta is equal to f. Okay, so t will be equal to f by 2 secant theta. Okay, so the acceleration of the particle is given by a naught is equal to horizontal component of tension. So it is t sin theta by m. So t is equal to f by 2 cos theta. So it will be f sin theta by 2m cos theta, or you can write this as f tan theta by, you can write this as f tan theta by 2m. Okay, and we know that tan theta is equal to x by root of a square minus x square. Okay, so it will become f into x divided by 2m into root of a square minus x square. okay, because this is a and this is x. So tan theta will be equal to, if this is a and x, this will be root of a square minus x square. Okay, so tan theta will be equal to x by root of a square minus x square. That's what we are substituting. So the correct answer is option number B, f by 2m into x divided by root of a square minus x square. Okay, let us now move on to the next problem. System shown in figure is in equilibrium and at rest. The spring and string are massless. Now the string is cut. The acceleration of mass 2m and m just after the string cut will be. So initially under equilibrium of mass m, we will be having the tension as T is equal to mg. Now we are cutting the string, therefore the force is decreased on the mass m upwards and downwards on mass 2m. Okay, so you are cutting the string and the force is decreased on mass m upwards and downwards on mass m2. So am is equal to mg by m, which is equal to g. So this is downwards. Okay, so this is downwards. Similarly, a2m is equal to mg by 2m, so which is equal to g by 2. So this is upwards. Okay, so g downwards and g by 2 upwards is the correct answer. So option number A is correct one. Okay, let us now move on to the next problem. What is the maximum value of force such that the block shown in the arrangement does not move? So the free body diagram of the block can be shown like this. You can draw the free body diagram for it. So it is shown like a dot here. Okay, so here you are having the force F cos 60 degree, the cos component, and here you are having the force over here, and this side it is mg plus F sin 60 degree, and this side you are having the force F. Okay, so this is the vertical force component and this one is the horizontal. So for vertical equilibrium of the block, you will be having N is equal to mg plus F sin 60 degree. So m is, here they are given you as root 3 kg. So root 3 g plus force, again here you will be having it as, you have to find out the force sin 60 degree is root 3 by 2 F. Okay, so for no motion the force of friction will be greater than or equivalent to F cos 60 degrees. Okay, for no motion F will be greater than or equal to F cos 60 degree. Okay, which because the angle here is 60 degrees, so mu n will be greater than or equal to F cos 60 degree. Okay, so you can substitute the values over here. Mu is, again they have given you 1 by 2 root 3. So 1 by 2 root 3 into n is root 3 g plus root 3 f by 2 is greater than or equal to f by 2. So when you solve this, you will be getting it as g is greater than or equal to f by 2, or f is lesser than or equal to 2g. Okay, so you know g value is 10, so f will be equal to 20 Newton. So the correct answer is option number A. Okay, so first you have to find out the vertical equilibrium of the block, and for no motion to occur, the force of friction should be greater than or equal to F cos 60 degrees. Okay, because it should not move. So you have to apply a force which should be greater than or equal to the horizontal component, okay, which is F cos 60 degrees. That's what we have written here, and you know what is the n value, you are substituting and you are finally finding out the force which has to be applied on the block in order to not to move it. So it is around 20 Newton. So the correct answer is option number A. Okay, let us now move on to the next question. As insect crawls upon a hemispherical surface very slowly, the coefficient of friction between the surface and the insect is 1/3. If the line joining the center of the hemispherical surface to the insect makes an angle alpha with the vertical, the maximum possible value of alpha is given by. So here you can draw the hemisphere like this, and you can draw it as a center like this. So here the insect is crawling over here. Okay, so you will be having here this as this one is the angle is the alpha. Okay, sorry, it's alpha, and this will be mg cos alpha. Okay, and this one will be mg, and this one will be the mg sin alpha. Okay, and this direction will be mu into n. So the equilibrium of insect gives here you will be having n. Okay, so equilibrium will be n is equal to mg cos alpha. So this is the equilibrium on one direction, and the other direction will be mu n is equal to mg sin alpha. Okay, so when you divide these two equations, you will be getting it as cot alpha is equal to 1 by mu. So we will be having it as 1 by mu is here the coefficient of friction they have given us mu is equal to 1/3. So 1 by mu will be equal to 3. So cot alpha will be equal to 3. So the correct answer is option number A. Okay, so beyond the angle of the repose, the insect will slip down. So the correct answer is option number A, cot alpha is equal to 3. The next question is, the pulleys and strings shown in the figure are smooth and of negligible mass. For the system to remain in equilibrium, the angle theta should be. Okay, so you can just draw the free diagram for M first. For the diagram of mass M, you will be having it like this. Okay, so here the force is mg, and here the tension of the string is T. So T is equal to mg. And now the free body diagram for root of 2m will be like this. Root of 2m, and you are having the tension over here like this T, and this angle is theta, and here it will be root 2 mg. Okay, so 2t cos theta will be equivalent to root 2 mg. Now you divide equation 2 by equation 1. Okay, so you will be having cos theta is equal to 1 by root 2. Like you are dividing equation 2 by equation 1, you will be having cos theta equal to 1 by root 2, or theta will be equal to 45 degree. Cos inverse of 1 by root 2 is 45 degree. So theta will be equal to 45 degrees. So the correct answer is option number C. Okay, let us now move on to the next question. A long horizontal rod has a bead which can slide along its length and is initially placed at a distance L from one end A of the rod. The rod is set in an angular motion about A with a constant angular acceleration alpha. If the coefficient of friction between the rod and the bead is mu and gravity is neglected, then the time after which the bead starts slipping is. So you can draw the diagram for it like this. You are having the rod over here, and you are having the bead which is sliding over the rod, and the force Ft, and this is Fc L. Okay, and here you are twisting the the rod is set in an angular motion, so you will be having here it is omega. Okay, so the tangential force Ft of the bead will be given by the normal reaction N. So centripetal force Fc is provided by the friction Fr. Okay, so the bead starts sliding when the centripetal force is just equal to the limiting friction. So Ft will be equal to m at, so which is equal to m alpha L, which is equal to n. So the limiting value of friction is given by Fr max is equal to mu n or mu m alpha L. Okay, so the angular velocity at time t is omega equal to alpha t, and the centripetal force at that time t will be Fc is equal to m L omega square, so which is equal to m L alpha square t square. Okay, so this is the centripetal force. Now equating equations 1 and 2. So this you can take it as equation number 1, okay, Fr, and this you can take it as equation number 2. So if we equate these two, because the centripetal force will be equivalent to the frictional force, when you equate these two, you will be getting the t value is equal to root of mu by alpha. So the time after which the bead will start will be equal to root of mu by alpha. So when t is greater than root of mu by alpha, what happens is Fc will be greater than Fr. So the bead will start sliding. Okay, so the correct answer is option number A. Okay, let us now move on to the next question. A block of mass 0.1 kg is held against a wall applying a horizontal force of 5 Newton on the block. If the coefficient of friction between the block and the wall is 0.5, the magnitude of the frictional force acting on the block is. So here you can draw the diagram for the block like this. You will be having it like this on the wall, and this is 5 Newton, okay, and this will be W, which is equal to 0.98 Newton, and this is N, and here you will be having the F value. Okay, so N is 5 Newton. They have given the horizontal force as 5 Newton, and F maximum is equal to mu into N, and mu value is 0.5. So 0.5 into 5, which is equal to 2.5 Newton. Okay. Now for vertical equilibrium, you have to calculate F is equal to mg, so which is equal to 0.98 Newton. So this is lesser than F max, okay, which is lesser than F max. So the value of force, the magnitude of the frictional force acting on the block is 0.98 Newton. So the correct answer is option number B, 0.98 Newtons. Okay, let us now move on to the next question. A car is moving in a circular horizontal track of radius 10 meter with a constant speed of 10 meter per second. A plumb bob is suspended from the roof of the car by a light rigid rod. The angle made by the rod with the vertical is. So here the force diagram of the bob is shown like this. You are having it like this, and you are having here the bob which is being suspended from the car. Okay, so this angle is theta, and this is the tension acting on it, and this will be the vertical component, which is t cos theta, and here it is mg, and here it is t sin theta, and this is theta. Okay, So T sin theta is equal to mv square by r, and T cos theta is equal to mg. So when you divide these two, tan theta is equal to, you will be having v square by rg, because m and n will get cancelled with each other. So here the v value they have given you as 10 meter per second. Okay, so 10 square divided by r value is 10. Okay, so 10, the radius is 10 and g value is 10. So 10 into 10. So you will be having tan theta equal to 1 or theta equal to tan inverse of 1. So which is equal to 45 degree. So theta is 45 degree. So the angle made by the rod with the vertical is 45 degree. So the correct answer is option number C. The next question is, a ship of mass 3 into 10 power 7 kilogram initial at rest is pulled by a force of 5 into 10 power 4 Newton through a distance of 3 meters. Assuming that the resistance due to water is negligible, the speed of the ship is. So here they are saying the water resistance is negligible, so we can take it as 0 or we can ignore it. So they want us to find out what is the acceleration, like the speed of the ship. Okay, first you have to find out what is acceleration, and from that you can easily calculate what is the v value, the speed of the value ship. So F is equal to ma, or A is equal to F by m. So here they have given you the F value as 5 into 10 power 4 and the mass is 3 into 10 power 7. So if you solve this, you will be getting it as 5 by 3 into 10 power minus 3. Now the speed is v is equal to root of 2 as. So it is equal to root 2 into 5 by 3 10 power minus 3, and the distance moved is 3 meters. So you will be writing it as 3, and if you solve this, you will be getting the v value as 0.1 meter per second. So the speed of the ship is 0.1 meter per second. So the correct answer is option number C. Okay, let us now move on to the next question. A piece of wire is bent in the shape of parabola y is equal to kx square, where y is y-axis is vertical with a bead of mass m on it. The bead can slide on the wire without friction. It stays at the lowest point of the parabola. It stays at the lowest point of the parabola when the wire is at rest. The wire is now accelerated parallel to the x-axis with a constant acceleration a. The distance of the new equilibrium position from the y-axis of the bead, where the bead can stay at rest with respect to the wire is. So you can draw the diagram first for better understanding. So here they are saying the bead is piece of wire is bent in the shape of a parabola. So you can draw the parabolic shape like this, and they are saying the bead can slide on the wire without friction. So you are having the bead over here which can slide over it without any friction, and here you are having force like this, and this is mg, and you are having here 90 degree minus theta x. Okay, so now you know that the components n sin theta is equal to mg and n cos theta is equal to ma. Okay, so when you divide these two things, you will be getting it as tan theta is equal to g by a. Equation number 1 and 2, if you divide, you will be getting it as tan theta is equal to g by a, or cot theta is equal to a by g. So cot theta is what? Tan 90 degree minus theta, which is equal to dy by dx, which is equal to 2kx. So on solving this, you will be getting x is equal to a by 2 kg. So the correct answer is option number B, A by 2 kg. I hope this video would have been useful for you to recall some of the problems relevant to the topic called laws of motion. I wish you all a good luck for your examinations, and thank you very much for watching this video.